I'm Vivek Myers, and I'll be presenting policy adaptation via language optimization. This is joint work in collaboration with Bill Zhong, Oyer Mays, Sergey Levin, and Quan Feng. Suppose we want a learned robot policy to perform a new task specified with natural language, in this case, putting the turnip in the drawer on this tabletop. One approach is to adapt a generalist policy to this task that has been pre-trained across a diverse set of behaviors. We could then fine-tune the parameters of this policy to the particular task. Unfortunately, existing pre-trained generalist policies often struggle to adapt to truly new tasks. Shown here, the RTX language condition policy fails to accomplish this task because it is not in the training data. For many tasks, overfitting and poor generalization properties mean we may need hundreds of demonstrations to adapt a pre-trained policy. Our PALO approach instead enables adaptation to new language tasks with as few as 5 demonstrations. Our key insight is that instead of fine-tuning model parameters, we can use demonstrations to decompose the new task with the help of a VLM. This lets us achieve much better scaling with a few demonstrations. At a high level, the PALO algorithm uses the demonstrations to select the decomposition of the task into language subtasks that the pre-trained policy will be able to do better. Given a set of demonstrations, shown here as the target, PALO uses a VLM to generate candidate decompositions. For each decomposition, we can compute the behavioral cloning loss of the policy across potential partitions of the time steps in the demonstrations. We can then define an overall cost J that is the sum of the behavioral cloning losses on each of these partitions for a fixed candidate decomposition and set of partitions. The PALO algorithm then jointly optimizes the cost across these decompositions and the partitions of the time steps, selecting the C1 through K that is able to achieve the lowest overall cost, which we'll denote here as C star. At evaluation, we can then condition the pre-trained policy on the subtasks in this C star to better perform the target task. We evaluate PALO across diverse tabletop manipulation tasks using 5 expert demonstrations. Shown here, PALO adapts to 4 tasks where the RTX model fails. Across the evaluation scenes, PALO is able to achieve better performance than the baseline methods, even those that use fine-tuning or nonparametric adaptation for the demonstrations.